With the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadow
Hello everyone. Okay, I guess we can turn the music down. And if I hear myself on YouTube, then we can get going. But I think it should be fine. Yeah, it is fine, surprisingly. So, let me just do a little adjustment to the camera. I didn't actually set it up before the live stream today, so yeah, but it's fine. So, officially, good evening everyone. And this is the 60th live stream, and today's topic will be ASan, or Address Sanitizer. And it's more of, I would say, like an exploratory topic where I will try to understand how a given thing works and show it to you at the same time. I kinda grasp the basic idea behind ASan. I never looked at the internals, I never looked at how it actually looks in the binary, so it will be kinda new to me, with some basic knowledge I already have about it, and I did use ASan in the past quite extensively, so should be fine. But it's not going to be the form of me actually explaining you the technology, which I know by heart, because again, it's like half new to me anyway. So yeah, you have been warned. Today's moderator is Foxtrot Charlie. You can see his nickname here. Yeah, if you have any questions at any time and you are on our YouTube chat, then do ask Foxtrot Charlie to convey the question. Well, just ask the question to Foxtrot Charlie and he will make sure I will get it. If you are on our IRC, you can do the same, or you can actually type !Q and then the question, and I will also get it. Let's maybe move it a little lower. Perfect. So, as usual, I will start the topic of the live stream around 15 minutes past, because that's, well, that's the way to basically wait for people who might be late but might still enjoy the live stream. And this is what I normally do, so yeah, I will do it again today. But we can get to some usual news and so on. Oh, I actually don't know what will happen now. Let me see, what do I have on my screen? Okay, let's see if the proper desktop shows up. It does, yes, I didn't test it. I should test it. As you know, I have actually 4 LCDs. And thankfully I have no passwords showing on any of them. So, yeah, but I prefer to double check if the correct desktop is actually being live streamed. And if I change LCD configuration then, and I do that frequently, then yeah, sometimes I do need to reset it. Perfect. Okay, so this is Foxtrot Charlie's blog, and he actually has written a post. You know, I usually like joke around that KrzaQ or Foxtrot didn't write anything on their blog, but Foxtrot did. It's like from today, I guess from a couple of hours ago or minutes ago, and it's a new post, so do check it out. I am going to give you a link to his blog. And as usual, I would like to thank Foxtrot Charlie for helping me with the live streams. It's actually really appreciated. Thank you. Okay. Next, if you go to my blog, or actually if you've seen my Twitter, my Facebook, or like half of the forums where I have an account, or Reddit, or whatever, then you probably already know that Ginvale's Summer Game Dev Challenge is up. And it's a competition which I do, I guess, every half a year. Before like a year ago or before 2 years ago, it was a little different, but now I do it every half a year. There's Ginvale's Winter Game Dev Challenge and Ginvale's Summer Game Dev Challenge, and it's a challenge, or actually a competition where you have to write a game, and there are some constraints. And the constraints are rather heavy, so it is a challenge. It's not like a competition to make a game, it's a challenge to make a game. And the constraints this year are, let me actually open it, and I will give you the link as well on the chats. Let's see what we have here. It's supposed to be a single-player real-time shooter, and I'm pretty okay with any definition of a shooter as long as the player gets to shoot some projectiles, lasers, or whatever. So that's fine. It can be 2D, 3D, whatever. The game has to be made in HTML, well, CSS, a little CSS, actually more JavaScript and WebAssembly. If you want to write, you know, in Rust or C++ or whatever, you can compile to WebAssembly nowadays. So that's actually a requirement. You do have to code it in JavaScript or WebAssembly, and it has to run for like under Chrome for Windows. So that's the test environment you should use. The size of the game is limited, so you can have multiple files, but like the sum of all the sizes of the files has to be 31,337 bytes, or about 30 kilobytes. And that has to include everything, like art, it has to include fonts, it has to include, well, fonts apart from the default ones, of course, default ones are fine. The code and whatever else you need. So yeah, that's actually a bigger limit, like almost over 50% bigger limit than we had on the Winters challenge. On the Winters challenge we had 20 kilobytes, and here you have around 30 kilobytes. Then you can have multiple files, as I mentioned, but the files have to be in the 8.3 8-letter name, 3-letter extension format. That's because, as was proven in one of my previous competition, you can actually use the file name to store some data and therefore bypass the limit, and that's not the idea behind the limit. So please do not try to bypass it with the file name, and that's why I have this restriction. And there can be no more than 20 files and directories in total present. So like, for example, 10 files, 10 directories is okay, still within the limit, but like 11 files and 11 directories is over the limit. And there is one more, or actually two more constraints. First of all, the game has to be in this resolution. The resolution is kind of funny because it's 360 pixels wide and 400 pixels high, which is weird, right? Usually you have more width than height, but this time it's the other way around. And actually it's supposed to stretch, like the canvas where you render the stuff is supposed to stretch to the full window, and I will test it on a normal LCD, which means that the pixels won't be like, you know, the standard rectangles. They will be more like bricks, so they will be rather wide but quite low. And you can display at most 32 distinct colors at the same time on a given canvas, in a given frame, sorry. So one frame, 32 colors, and I will use, you know, some clever mechanism to actually count the colors. So yeah, it's not about me checking optically if there are 32 colors. It's like some algorithm running and checking if there are 32 distinct colors, judging, of course, on the 24-bit hexadecimal value, well, value of the color, yeah. So these are the restrictions, and there are rewards. By the way, the deadline is 2nd of September. There are some more rules, please do read them. The rewards are this time, and it comes as a gift card to either Amazon or Steam, or I can make exceptions in some cases to another store. It will be 200 USD for the first place, 150 USD for the second, and 100 USD for the third place. I might do some honorary awards as well, or an honorary mentions, which will be awarded with 50 USD gift card. Sorry. There are some notes on how I will judge the game, some pro tips, and a rather extensive FAQ. I do encourage you to participate. There will be... So it's basically like this, like I mentioned already on some of my previous live streams. These competitions are fine to take part in if you're a beginner, if you're intermediate, or if you're like a pro, right? If you're a pro, your approach will be probably different, and I don't have to tell you anything about it. If you're a beginner, then it's a great opportunity to learn a lot of stuff. And if you're intermediate, then it's a great opportunity to focus some time on one project which has a clear deadline, and I hope which is fun to make, and, you know, and polish your skill basically. So if you, by the way, want to take a look on the previous year challenges, then you can go to my blog and look for Ginvale's winter challenge, for example. So let's try to do that as soon as this actually doesn't bug out. Ginvale's summer, I want winter. Yeah, here we go. Yeah, so last actually half a year ago, the limit was 20 kilobytes in JavaScript, though there was no resolution limit. It was just like do a game in browser. And yeah, folks made like really cool games, so, and they looked really nice too. So totally, it's like doable. You can do a game which is only 30 kilobytes, and I encourage you to try. Okay, speaking of other challenges, you know this theme, like Dragon Sector, right? This one. We are making a CTF, well, which is expected, kind of like we do one every year. And there will be a teaser phase, like a teaser CTF with some prizes, and a main CTF. The teaser CTF will take place on, sorry, I have this in Polish, this is September actually, 29th of September, starting at noon UTC time. It will be several tasks, I guess around 10 maybe. It will be online, like the standard Jeopardy format, and you can win some prizes. The weight will be, by the way, 25. The prizes will be basically invitation to the offline event, including travel allowance and hotel for up to 6th place, then that's only the invitation plus the hotel without the travel allowance, and up to 10th place there's the invitation to the offline events without any costs being covered. On the offline event, which will happen on 19th of November, it will be is it here? Yeah, it's here. Here we go. It's 19th of November, the list here is for November. It has a rating of 66, and there will be, these will be the prizes. 10k Polish zloty, which is around $2,500 for the first place. Then I guess this is a little more than $1,000 for the second, and I guess it's around $500 for the third place. This will happen on the Security Pwning conference, which I'm co-organizing, so yeah, it should be fun. I totally encourage you to participate. Did we get, did Dragon Sector get 666 on purpose? No, that's just how math works, but it's quite funny. Yeah, especially it would be funny if it would be like 777, but it's not. Cool, so I guess we have 3 more minutes to do some questions, and then we can switch to the main topic of today's live stream, which is again Address Sanitizer. Let's see if there are any questions. The questions should appear here in the bar underneath me. When do you plan releasing new book? I do not plan releasing a new book. I do plan on releasing the 2nd edition of my Understanding Programming book, which this will be the 1st edition published in English and the 2nd in Polish actually, and I hope this will happen at either the end of the year or at the beginning of the next year. Yeah, the original book was in Polish. It was well received. It was like, I actually got some awards for it. It was considered a bestseller, I guess, but that doesn't mean much in IT in Poland, I guess. Anyway, and it was 600 pages of, well, pretty technical stuff about programming and the environment of programming, as in the operating system, the CPU, basic like IPC mechanisms, sockets, file system, and so on, basic types, how what are the problems with them, and so on. So yeah, more information on this will come in a couple of months, I guess, when I'm somewhat ready to release the table of content, and I'll let you folks know. When will be OS Dev stream? I don't know. In English, on English live streams, we never actually did it. When Foxtrot Charlie will be making a blog entry. Ha, he did one. What about a live stream? Maybe Foxtrot could make a live stream. Yeah, we can chat with him about it. Okay. Oh, this is actually on topic. What's the performance impact of ASan? It depends, but it's not huge. But I will talk about it later. I think they claim that it's around 2 times, like the application is 2 times slower, which is pretty good for what it does, but let's chat about it in a couple of minutes. Is ASan a good idea for kernel mode code? Yeah, I think there were some experiments with it. I'm not sure what's the state, actually. But yeah, I mean, the idea is pretty generic. It can work anywhere, but the ASan I will be talking about today is only about the user mode stuff. Is it a good idea to keep ASan running all the time while development? I don't see why not, apart from, you know, it actually does decrease performance, and the question is also, do you want to have it running on production or something? But yeah, I will again touch on these subjects in a couple of minutes. It is a good question. I don't see why not. I would totally run tests. Like in production code, I would run tests with ASan and without ASan and with some other sanitizers, because why not? Does ring -1 and -2 exist? So ring -1 and -2 are actually like, there are no official ring -1 and -2. Ring -1 is what's being called on the scene. And I think that's due to the folks from the Invisible Things Labs. Anyway, -1 is the hypervisor, and -2 is the system management mode on x86. So this is how you usually refer to them, you know, speaking amongst ourselves. Is again not official terminology. Official terminology is the hypervisor and SMM, like system management mode. But you can refer to them like ring -1, ring -2, and folks will usually know what you're talking about. Yeah, some folks call it the Intel management engine ring -3. You know, like to follow basically this. And it has some sense, because that's basically how, like, the privilege level of the things, like things which are running on ring -1 have basically more privilege than whatever else is running on the system, and -2 have more privileges than even the hypervisor has. And management mode again is, well, it's like kind of operating outside of a CPU, but it has quite a lot of privileges on the system itself. Then also we have, you know, Intel SGX, which is another thing which might be one of the minus rings right now. Will your book be someday available in English? Yes, it will be. Again, at the end of the year or beginning of the next year. There's KASan for Linux. Yeah, that was what I was referring to. Like kernel ASan. Any suggestions for books and resources for machine learning in Python? Absolutely no. I have no idea about books for machine learning. So, yeah, sorry. Do try to... Well, one thing you can look for is, you know, TensorFlow books. That's pretty popular right now, and there are bindings in Python, really good ones for TensorFlow. Okay, so I guess we can start chatting about today's topic. Let me move the microphone a little. Let's see if it's a little better now. Yeah, I actually did get a really good email from one of the viewers about the microphone being a little quiet and the music being a little loud. I will try to look into it, but later. By the way, 2 more things on the organizational side. One is there will be no live stream next week or in 2 weeks, because I'm actually on vacation. And second is that there is no mission today. Sorry. Okay, well, last question. How to get security job at Google? Okay, how do you get a security job at Google? You go to jobsgoogle.com or something like that. I don't remember. No, careersgoogle.com/jobs, and you look for security. Here we go. Then you select whatever security flavor you are most interested in, and you click, like here, for example, ISE. That's actually the role I'm in. And you click apply, and then you submit your resume, and then if your resume is good, you have interviews, and if you do good, then you get a job. That's basically the idea. Nothing to it. In all honesty, the interviews aren't easy. So yeah, you have to be pretty good. But yeah, try it. Okay, so let's chat about Sanitizer, ASan. What's ASan? And because I guess you kinda know from my live stream, so you might have heard. ASan, or Address Sanitizer, is basically a plugin for compilers. It's something which you, well, it's usually visible to us as an option for the compiler, like -f sanitize equals address, and it's instrumentation, which is added by the compiler when compiling the code, which is supposed to detect certain kinds of, well, undefined behaviors or actually security problems. Because, well, security problems are sometimes undefined behaviors in C or C++. For example, Address Sanitizer, which is one of several sanitizers, there are a couple of them, detects like buffer overflows to some extent, use after freeze, and yeah, basically a couple of other memory-related issues. I will get to what exactly in a moment, and we will also take a look how it exactly detects them. But the idea is that you compile your code with it, your application, right? And you, for example, run some tests or on the application afterwards, or like just run the application and try some funky stuff with it, or run the application in a fuzzer and fuzz it extensively. And what ASan gives you is it gives you detectability of the issues, because for example, even if an issue is triggered, right, the application might not crash because it's, I don't know, 1 byte buffer overflow into some padding area, and in this compilation it might not crash, and in the next compilation, due to compiler changes, it might be actually a problem. Well, ASan can detect it, right? So it's really great to use ASan when fuzzing and doing other kinds of tests, because it can detect issues which are there. And the detection is all done at runtime, so this isn't static analysis of the code. It's more like if something actually occurs, then you get a report about it. So this is what ASan is. Now, ASan was developed originally for Clang, which is, LLVM C compiler. It also was ported to GCC. I'm not sure what's the state of the port, but usually it was a little lagging behind. So for the newest version, you probably need Clang, and or Clang, however you want to pronounce it. And yeah, I actually downloaded Clang today and compiled it. It didn't take too much time. It was rather like easy, just follow a few steps from the description. And that's what I will be using. I think it's Clang version 7. Now, yeah, so this is the basics. Let's actually try to create an application with Clang and see what's going to happen. So I'm going to open my Linux console. Here we go. Okay, their best supervisor says it's Clang, not Clang. I don't know, Clang has a better ring to it. Yeah, I will be probably using both names today, changing them. So let's start with with what? With actually getting the right Clang, because I think by default I have Clang version 4 installed by my Ubuntu, but I did compile it today. So I have a Go file, go.sh file, which actually exports the path to where I compiled it to the path environment variable. So I'm going to run with a .gosh to make sure that actually it's in my in my bash's environment. Here we go. And now if I run Clang version, I should get 7. Perfect. Here we go. So yeah, somewhat new. Now I need to run some code which is vulnerable, because we do need to get an exception. I'm going to name my file asdf.c. I follow the usual convention. What? No, I see you're discussing on chat how do you pronounce Quewe. Quewe is pronounced Quewe. It's the only proper pronunciation of Quewe. Quewe. I'm sorry. It's not Q, it's Quewe. Okay, let's be serious. So yeah, like, I don't know, the most generic buffer overflow program you can write. I'm pretty sure that I cannot write gets, because Clang will say no. So I'm going to do something else. Let's do a buffer of 4 bytes, and I'm not going to even initialize it. I'm going to do scanf with %s. This is a buffer overflow. It should be 3s, like 4 minus 1 should be here, but I'm not doing that because I want a buffer overflow. So yeah, that's it. Now, just for fun, I'm going to output it. just to be sure that, you know, like dead code optimization won't remove it based on the fact that I'm actually not using the output of BAF, but no, it shouldn't remove it because scanf actually has some side effects, so never mind, I do not have to output it, but that's fine. Okay, I'm going to compile it first without ASan. So clang or clang asdf and yeah, compiled. I can do even wall, let's see. Yeah, no, there are no warnings. Like we have a buffer overflow, we see a buffer overflow here, but no warnings. This is the usual deal, you know. So I'm running it without ASan, and I'm going to do 5. 5 is an overflow already. It didn't crash. It was an overflow, it did overwrite 1 byte on the stack, but it was some padding probably, but it didn't crash. So now I'm going to do some more A's. And yeah, segmentation fault, core dumped, because I overwritten the return address and it outputted it, tried to return from the function, and I got a crash, a basic buffer overflow. Now let's try this with ASan. So what I'm going to do is I'm going to compile with an option F, -F, sanitize equals address, because again ASan is for Address Sanitizer. And now let's run it. I'm going to try 4. Oh, and it already overflowed. Of course it did. No, why did it? Okay, 4 shouldn't, maybe should. 4 shouldn't overflow it. That's quite funny. Let's do a lot, and then we will try to figure out why doing just 4 overflowed it. There might be. Oh no, it's quite obvious why, because 4 actually does overflow it, because that's 4 A's and there's then, you know, the terminator 0, so that's 5. Yeah, that's an overflow. This is an overflow as well, and this is how an ASan reports that it has a stack buffer overflow. This isn't correct, obviously. It's stack-based buffer overflow, but like we know what's going on. We know that it's a stack-based buffer overflow. So stack buffer overflow, whatever, that's fine. It says what's the address, it says what's the PC. Address, which is, you know, on the stack, which exact byte was the one which was overflown into. Then what instruction did the overflow happen at. And we have some, like a stack pointer, I guess. So the stack, we can see just by the stack pointer, but yeah, this is on the stack, like 7FFCA something something. So that's fine. Oh, I see you're writing on the chat that it's a null byte. Yeah, it was a null byte. Yeah, then we get some information on what exactly did overflow. It says that it's a write of the size 21 bytes. This is, I guess, the amount of A's I did enter. And yeah, it was in scanf, which was called from main. This is quite a lot of information, actually. So it's really good. It also tells us, I guess, where the buffer was allocated. In case of a heap-based buffer overflow, it would tell us where the buffer was allocated. And this is quite useful because we get both the information where the buffer was allocated and where was it overflowed. And the first information, like where was it allocated, is really important because otherwise we don't know. It's just like some random memory on heap. How do you get back from that to the code location which is actually related to? Well, maybe you can by the just looking at the area where was it allocated. Sorry, where was it overflown, but it's great to have more information. Yeah, it also tells us actually which object, like which variable or array was overflown. Memory access at offset overflows this variable. And there are some hints, but that's fine. And this is the shadow bytes, and we will discuss what's a shadow byte in a second. But basically, this shadow bytes, it tells us how does the memory around it look like, as in how many bytes around are allocated and which bytes are allocated or not allocated. That's actually an internal mechanism for ASan. You rarely look at it. But if you need to debug ASan, this is probably something rather important for you. Yeah, so yeah, we'll get back to this, I guess, so I'm not going to go into details right now. Now, what I'm going to do... oh, you want to try this one with everything. Let's try everything. yeah, still no warnings about the buffer overflow. So what I'm going to do is I'm going to do like ggdb, I guess, to get some more symbols into ASan, and now I'm going to again overflow it. Let's go with 4 this time. And you should get even the the line numbers, the exact line numbers where the overflow happened. It says that line number 3, line number 6, and yeah, it is in fact line number 6. So quite a lot of information about the exact thing which happened without even running the debugger. We just get it straight from ASan, which is amazing. I mean, the tool is really great. Is there something more interesting here to look at? Oh, you want also -03. Okay, let's try -03. And let's run it. Let's try this. Yeah. So -03 doesn't say anything. Now let's try ASan with -03, I guess. Okay, running overflow, and we get the report. And it still should work fine. Yeah, we still, even for optimized version, we still get version. I guess the layout is still different, but that doesn't matter. Cool. So yeah, this is basically how ASan works, and this is what ASan is about. We will get into details in a second. I do want to give you a link to the Wikipedia. Well, Wikipedia, not Wikipedia, to a Sanitizer wiki on like Google/sanitizers. And yeah, there are like other sanitizers mentioned as well. There's the address, which today's episode is about. There's the leak sanitizer. It's actually, I think, run as well. If you're running Address Sanitizer, you're running leak sanitizer by default as well, if I remember correctly. Then there are some other things like thread sanitizer, memory sanitizer, and I think there was also like undefined behavior sanitizer for other types of sanitizers. You might want to look at them, especially if you're writing production code in C++. Look at them, include them in your tests. It's pretty useful stuff. And if you, by accident, read Polish and actually subscribe to the Programista magazine's, like a paper about programming in Poland, then Mateusz Jurczyk from like Project Zero Dragon Sector did write an article on how does ASan work in Polish. So I'm going to give you a link as well, just in case you have it on your shelf and speak Polish. By the way, there are some, like for example, this link here, Address Sanitizer algorithm. This is a description how it works. So if I'm short on details, do look at it. Basically, do check it out. Yeah. Cool. And there are some papers as well. By the way, Address Sanitizer has a great track record. Like for fuzzing, which I did or we did with Mateusz, it helped find like hundreds of bugs, and I do literally mean hundreds of bugs. I think most of the stuff we just found with FFmpg, and if you might remember that we found there, I think 1,500 bugs, some of them, well, security related, some I guess only led to crashes, but yeah, most of them were found with ASan. So yeah, ASan is amazing. Cool. So now let's try to like think what, oh wait, that's not good. I just got an information that I'm running out of disk space. That means my stream would not be recorded, but okay, I deleted some random files, what could possibly go wrong. Perfect. So now let's think about how it works, and starting with buffer overflows and so on. And actually it's also the same for the other mechanisms which are implemented in, for the other bugs which are detected by ASan. There is, as you can see, a shadow memory or shadow mapping. So the idea is basically, is rather simple. For every, let's say, block of memory which you have allocated in your program, be it stack, be it whatever writable block of memory, right? Like heap, stack, data section or whatnot, there is somewhere in memory a shadow section, which is 8 times smaller, and where actually one chunk of this section, like for example one variable here, maps to give or take the same location here divided by 8. And this is what's displayed here, is actually the shadow memory. Now, so yeah, Address Sanitizer actually uses more memory, and 1/8 of memory more than usual. If that's only, by the way, about actually allocated memory. If you would look at reserved memory, I think it reserves around 16 terabytes right now or something, or at least it did it in the past. So, but that's reserved memory. Reserved memory is not committed, it's not allocated. That's fine for it to be reserved. Okay, and this is how it looks like. Basically, each byte in the shadow memory represents 8 bytes in normal memory. Initially, I thought that it would be like, yeah, that's because like a byte has 8 bits, and you can mark which byte is allocated just by marking bits. But they actually went a different way. What they did is, and we can see it here, is basically a number 0, or number 0 basically means that all of the 8 bytes are addressable. The addressable means allocated, and like yeah, for proper use, like not being some guard variable or anything like that. So yeah, zeros means addressable, so all of this stuff is actually addressable, because I will get to that later, but there's a reason. Then these values represent partially addressable, and partially addressable means actually that if you have 8 bytes, right, lower addresses being here and higher addresses being here, then, for example, if you have 3 consecutive bytes being allocated, so the yellow stuff being allocated on a logical level, on a compiler level, right? And the rest being not allocated, being some padding, being some like utility variable used by the compiler, for example, the stack cookie or the return address or the argument of a function. Well, the argument, never mind argument, but like the other things I mentioned. But it's actually not addressable or not allocated. The application should never directly address them, because that's only done by, the utilities inserted by the compiler. So this is a red zone, right? A no-go zone. And so yeah, 3 bytes allocated, that means you put 3 in the byte. This poses an interesting problem. Like, what do you do if you have 8 bytes and then you actually have like this byte allocated and this byte allocated, then you have the red zone for this byte and this byte, but then you have like another 2 bytes allocated. What value do you enter then? And this is actually problematic. ASan strongly relies on memory alignment to 8 bytes, which means that under normal circumstances, this should never happen. Like in memory, if you compile something with ASan, it shouldn't happen unless you force some weird alignments. And then it will be not detecting things properly. There are some limitations to ASan, but I don't think there are ways to fix it, obviously, but you would lose some performance, and sometimes it's a question about like how much performance do you want to lose versus how much things do you want to detect. You probably are not going to detect everything, and I will mention that in a second. Then there are some special values which indicate non-addressable memory. They're all, well, values with the highest bit set, which are actually negative. Let's call them negative values. I think that's what the official documentation calls them. So yeah, like the red zone is again the no-go zone. You have different types of it. For example, if you have a variable or array on the stack, then you might have the left red zone, which is on the left side of the stack. So this would be marked as F1. Then you have the middle red zone. I think that's the padding to the to 8 bytes of a given variable. So this would be F2. I think. I'm not sure. And then the right red zone, which is after the variable. And the red zones here, I think they were like 32 bytes long. So basically every variable is supposed to be, or actually I'm not sure if every frame or every variable, we can check that in a second. But the idea is that you have a variable and then you have the red zones, and the red zones have some specific values well, that doesn't matter. They don't have specific values. They are checked. If there is something trying to write to one of the red zones, that means that there's something fishy going on. For example, there is a buffer underflow if you go into the left red zone. There is overflow if you go into the mid or right red zone. Or it might not be either of them. It might not be a buffer overflow or underflow. It might be some relative right what where condition which actually happened to hit a red zone. That might also happen. And yeah, you have also different kinds of other stuff basically marked in the shadow memory according to the meta information known about it. So this is basically why they didn't go for using bits to say if a given byte is addressable, because we wanted to include some additional meta information about the nature of the memory. So if we look at our buffer, right, we can see that, there is no F2. So yeah, we might want to figure out what F2 is about. We do see on the left side, we have F1s, 4 of them. I did mention that every byte in the shadow memory stands for 8 bytes in the normal memory. That means we have, well, 4 times 8, 32 bytes of left red zone on the stack. Then we have, we have only 24 bytes, I guess, for on the right side of the red zone for some reason. And then we know that the buffer is actually at the beginning of the 8-byte boundary. This is our buffer. And we know that then there is a no-go zone, a non-allocated memory, right? 4 bytes of them, because, well, that's what is left. 8 minus 4, that's 4, so this is 4. So, what Address Sanitizer will do if we actually go and try to use the memory, it will instrument all the places in the program where memory is touched, and it will do a check. It will get the address of the shadow memory for that given byte which we want to address, or like dword or whatever. In the shadow memory, it will get the address, and it will check. Is this is basically a byte describing the address in the program, in the operational memory, in the application memory, which the application wants to access. Is it allocated? Is it addressable? Can the application actually access it? And well, in this case, which I marked, is F1, is like red zone. No, it's not allocated. It should never be touched. And ASan will actually go into this output report and terminate mode. Otherwise, if it would be, for example, 04, there would be, I guess, an additional check. There could be an additional check whether this is actually correctly the correct part of the variable is being addressed. Or if it would be 0, then it would be just fine, that's fine. Actually, like, all the 8 bytes are allocated addressable, so that's fine. So what we see here is actually, look at our program, it's pretty small, right? There's the main function and nothing more, and we have one variable in the main function, right? So given this, Address Sanitizer, it starts with a process which is just booting, and it doesn't know anything about what, I guess, the code, which is not here, not part of the program, did with the memory. So just to be safe, it, I guess, marks all the memory with zeros, meaning it's addressable. And it only marked the stuff which is actually certain about what kind of memory it is, as well the red zone, or then the variable, and then again the red zone. And all of the other places are actually addressable. This means that if we wouldn't have a buffer overflow, or we would have a funny buffer overflow where you, instead of writing each byte one after another, you actually write one byte and then skip by, I don't know, skip by 100 or whatever, and then skip by 100 and 100, and you basically, okay, I guess you don't see it. Yeah, you skip, you write at 0, then you write at 100, then you write at, and 200 and so on. That would mean you would write probably into the buffer, then skip 100 and would hit the memory, which is actually doesn't belong to the buffer which you started with, but yeah, but it's still marked by ASan as being addressable, as being allocated, so ASan would not detect this condition, and we can check it in a second. And yeah, these kinds of bugs do happen. I did find a couple of them in the past, so it's good to know the limitations of ASan. ASan is amazing; it's an amazing tool, but due to reasons, there are some constraints, right? Cool. So let's try just that scenario which I mentioned. So instead of doing this, I'm going to do something else. I guess I'm going to do like for and I equals 0, I less than 100, I plus equals 40. Yeah. So this will actually, yeah, that's cool. And I will do bath of I equals to get char. So first we get 0 here, then we get 0 plus 40, 40, right? 40 is obviously totally out of the buffer, but given that, as we can see here, Address Sanitizer doesn't have any information about the other memory, which is before the stack frame of main, it should not detect it. Let's see if actually ASan isn't smarter than me, so we can take a look. I am going to remove O3 because O3 might actually decide that, hey, this is like, yeah, nothing interesting is going on here. I'm going to remove some code. That's the danger of O3 and experimental code. Like in production code, that's fully acceptable, right? But if it's experimental code which doesn't actually use all the variables, then yeah. Yeah, now I need to enter some variables. I'm going to enter 5. It doesn't matter that I entered 5, it's actually read only 3 of them, like 0, 40, and 80. And then it went out of the 4. And yeah, ASan didn't complain, so ASan didn't detect this, so this is one of the limitations of ASan. And again, that's okay, it's just good to know about it. Now, how am I sure that ASan is actually running? You can actually pass some variables which come in the form of an environment variable to ASan, variables as in options, and it's called ASan option or options, I think, equals, if I do verbosity equals 1, it will actually output some additional information. Yeah, so this basically tells me that ASan is running. There is some map of the shadow memory. It's actually like pretty cunning how they mapped memory on 64-bit. I guess we can chat about it later. Yeah, and it's waiting for me to enter stuff, and yeah, and that's basically it. So, okay, let's. I guess we can chat about this. I guess there's a question: what is the shadow gap? This is actually pretty amazing. And yeah, my information is coming now from an article by Yuru in Programmista magazine, which I mentioned. I did read the explanation to this there. It's actually like this, because on 32 bits, right, it's somewhat easy. You have a 42-bit address space that's actually like 4 gigabytes, right? 4 gigabytes. And that's not a lot. Well, it was a lot back in the old days, but now it's not a lot, right? So this is the whole memory, and like kernel eats some of it. This is like the kernel on Linux. On Windows it would be half of it, but doesn't matter. And then you have a lot of memory, and you can just like say that, yeah, this part is actually ASan shadow memory, which is used to map all of this, right? All of this is actually being mapped here. That's easy. Only 4 gigabytes you can allocate. What was the amount? It's 3 gigabytes. So 3 times 10 to the power of 3. This is 3 gigabytes. You divide it by 8. And you get, what's this number? Yeah, that's like 400 megabytes. That's nothing. You can reserve 400 megabytes. You can even allocate 400 megabytes on most of today's computers without any problems. And that's easy. Now, on 64 bits, we have a little larger address space. It's not 64-bit, right? At least on x86. It's more like 48 to the power of 48, maybe a little more, but something like that. So that's a little more than 4 gigabytes. How much is it? 2 times 48. I might be wrong on the 48, by the way, because there are some flags in the CPU that you can make it a little larger, but that doesn't matter. Let's not go over. Yeah, so kilobytes, megabytes, gigabytes, terabytes. So yeah, 281 terabytes. That's quite a lot. Now, if we divide it by 8, that means just, you know, subtracting 3, because, yeah, 8 is 2 to the power of 3, so we subtract it. And how much memory would we need? Well, we need quite a lot of memory. Thankfully, it's what, 35 terabytes, kilobytes, megabytes, gigabytes, terabytes. I think I missed gigabytes, didn't I? Well, whatever. That's quite a lot of memory. So you cannot just do a mapping 1-to-1, because that would take quite a lot of address space. Or I guess you could, but you might be able to reserve it. The question is, should you? Another way to do it is, you know, to, like, in a super slow way, if you're fine with it, you can do a hash map or a tree or something. But then asking about the shadow memory about a given byte would actually mean that you'd have to find the address in the tree or hash map or whatever, and that would take some time, and that would greatly slow down the application. So like, for example, think of how the page tables are structured, right? That basically gives you the idea. So they did it in a little smarter way, which is, this is basically the map of memory, and you have it split into low memory, low shadow, then the shadow gap, high shadow, and high memory. And the idea here is that if you take the memory address, so the shadow memory is basically like, you have the memory, right? And the shadow memory is around here, like in the middle. It's not really really in the middle, it's like lower parts of the middle. So this is the gap, which is not used. I think the gap is not used by anyone. So this is the memory which is not allocatable and it's not used. Then you actually have the high shadow area and the low shadow area. And then you have the memory which can be used. So this is the memory which can be allocated and can be used. Now, if you actually divide the address by 8 and add, yeah, I think basically just divide the address by 8, if I'm not mistaken, or do some other like really simple math operation. We can look up it in a second. This area will basically fall into this shadow mapping, like and this area will fall into this shadow mapping without you having to distinguish which part of shadow mapping are you referring to, like the higher or the lower. I'm not explaining this clearly. I guess we can take a look at the documentation. It has to be explained somewhere here. Yeah, here we go. Yeah, so 32-bit, 64-bit. Yeah, exactly. You divide it by 8, as I did mention, and you add the address. Oh, I was thinking you actually highlight a bit, but okay, you add an address, and using this formula, you get either, like, if you use this formula for anything in the high memory, you will get these addresses. And if you use it for anything in the low memory, you get these addresses. And the middle part would map into itself, right? So you cannot actually use that. That's why there has to be a gap, which is unusable. So that's actually pretty smart, and I really like how they did it. I guess on 32 bits is done the same way right now. I think it was done a little different back in the days, but yeah, my memory is kinda old. Okay, so yeah, so this is basically how you get the address in the shadow memory of the metadata. So now we can take a look on how does it actually, what kind of instrumentation does ASan include into the code, right? Because again, it's compile time instrumentation, which means that the assembly code you get, there is more of it. And to do that, we can try a funny thing. Let's see if Godbolt actually supports it. If not, we can do it on like on my console, but godbolt.org, which is a compiler explorer, which is privacy policy, blah 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 blah. Rodo is it? Oh, that's from US. That's funny. Why do they need to do allow cookies? Okay, I guess I have a browser setting which says allow cookies, and whatever. I know you have to ask about it. It's quite funny because when the web started, the browsers asked you about every single cookie. Do you want to allow the site to have the cookie? If you like run Internet Explorer 4 or Internet Explorer 3, it would ask you about every cookie. And then like folks said, yeah, that doesn't make sense. Like users don't care about cookies anyway, so whatever, let's do just a browser setting that disable cookies. And then a few years ago, some laws were passed and we have to, well, the websites have to ask about cookies again, which is going back to the old problem, I guess. Okay, Clang 6, that's fine. This doesn't matter, this doesn't matter. Let's do some global buffer. So buff 3, that's fine. And we do buff of A equals A. So this is, yeah, so this is, no, wait. Yeah, without flags. That's fine. Okay, so this is how it's compiled. I'm going to do void here because otherwise it's undefined behavior. Well, what's going on here? In EDI we have a parameter, right? The argument, and it's being stored in a variable. We don't care about it. Then we, then yeah, you get the low. Dil is actually the low byte of EDI. Like di low is the naming in 64 bits. Then we get the buffer address, I guess, yeah. Here's the buffer address, we add RCX to it, so again, RCX is like EDI is our argument, right? Because it's stored into this variable, and we have it here, so this is our argument, this is A. So this is basically A is equal to A, is just a write to the memory. Once we have in RCX and AL the proper arguments, it's just a write to the memory. Now, let's see how this memory reference actually looks in ASan, but ASan actually should, yeah, no, that's fine. That's fine. We need -f sanitize equals address. Yeah, it supports it. Perfect. A point for Godbolt. I do need to move the screen though, I guess, a little bit so you can see it. Cool. So now, as you can see, the yellow part, there is quite a lot of more code. I'm actually going to do O2 in hopes that a lot of that code is going to disappear. It did. Perfect. So again, in EDI, we have the address, which is our A, our parameter, right? This A. And then it's passed to EAX, then it's passed to RCX, sorry. So in RCX, we have well, A. Again, so this is A. Then in RDI, we put the address of the buffer plus RCX. So we basically calculate the address of this expression, like where does this expression point to? And it points to, well, this address which now we have in RDI. Then the formula which I showed you is being calculated. We have the address and it's first going to be, so the address is in RCX right now. Well, it's shifted right by 3, and then we add to it the number like +2, 1, 4, blah blah blah. Let's see this number in hexadecimal actually. So hex, and yeah, it's the same number we saw on the wiki I was showing you in the formula a few seconds ago. So this is the shadow memory for ASan, or actually the value which is used to calculate the address of a shadow memory. And it gets a byte from that shadow memory. If the byte is 0, so if it's not 0, then we go here. Otherwise, we go here if it is 0. If it is 0, it means you don't have to do any more checks, it's allocated, whatever, that's fine. It's okay for you to refer to that byte. And as you can see, this is the code which we had originally in the previous code without ASan, right? So the think if in AL is actually written to the address which we have calculated. Not calculated, but we have in RDI. Well, yeah, we calculated it because it's buffer plus whatever we have in A. Otherwise, if it's not 0, so if it's not in the if it's not in one of the allocated regions, like fully allocated or fully addressable, then we go here and we need to do additional checks, right? I guess it checks, like first of all in EDX it puts the lowest bits, then it checks if compares DL and CL. What's in CL? In CL, okay, I guess it checks whether it's negative. How would this check work? So yeah, in DL we have the version without the highest bit. Okay, so it's like this. These two are either equal in case the lowest, so if the highest bit was not set, then these are equal. If the highest bit was set, then this will be smaller and this will be larger. So for example, like let's assume it's F7, right? So the left one after the end here would be, the top bit would be removed. So that would be, I don't know, what would it be? F minus 8. That's 7. So yeah, it would be 7, 7. And the right part would be still F7. So yeah, so this jump would be executed in this case. If the highest bit is set, then this jump would be executed. Am I doing it correctly? Yeah, because this one will be lower, DL would be lower, and we would jump. Oh, am I doing the math correctly? This is quite tiny. This is missing one thing. Why does it... No, I think I... Oh yeah, now I get my mistake. I was thinking it's actually taking the CL, but it's taking EDI again. This is again the address which was calculated. So that's my bad. It takes the address and it... Okay, that makes more sense. And it actually checks if the lowest bits of the address are within the range. So yeah, that makes a lot of more sense. So let's do the math again, just to be sure. Let's assume that the address is, in our case, the buffer will be on an aligned position, so it will be probably 0, right? So 0, it will be just 0, and there won't be anything interesting happening here. It would be 0 here, and the CL would be, CL again is the byte which was taken here. It would be 0 for allocated. So if it's for allocated, then it's jump less. Would jump less, how would that work? It wouldn't jump, or would it? I'm getting lost by this math. Is it very... yeah, it is the calculated. It should be 0, assuming that we have... Oh, no, because it won't be 0 there. Basically, it's funny because I understand what's the logic behind this. The logic behind this is they're trying to do with one check, they're trying to do two things. First of all, they're trying to figure out if this is allocated, because if it won't be allocated, then one of these values, this is by the way a signed check. So this is jump less, this is not jump below. Yeah, if it's, if this is negative, they want to go here. Or if the address is actually, if we have, like, for example, in the shadow memory 03, meaning that 3 bytes are actually allocated and this is not allocated, this is supposed to be a red zone, then they want to check if the address, the last 3 bits of the address, is more or is it more or is it less than 3? If it's less than 3, then they want to jump here, which is fine. If it would be more than 3, for example 4, right, it would fall into the red zone. And that's what they want to, that's why they want to go here. What I don't understand if it's, oh, right, because I was thinking about, you know, putting zeros as the value, but that doesn't make sense. If it goes to this part, then I guess the values from the shadow memory that cannot be zeros. It has to be, for example, 03, because the zero check is here, right? So yeah, if it's 03, so let's do the math again. I assumed that we are writing to the beginning of a buffer, then it would be 00 in DL. Then the CL would be 03, then 00 is less than 03, which is fine, and it would jump here. That makes a lot of more sense. If it would be like, for example, F7, some kind of a red zone, then this would be a negative value, and this would be 00 again, right? So this 00, and this is F7. F7 is a negative value, meaning that this is less, and this is more. And if it's more, then it goes here, and it calls the ASan report store1. Store1, I guess, is for like, this is a check for 1 byte write, so store1 means like this is generate a report for 1 byte write. And I guess this makes a lot of sense. Now it makes a lot of sense, so yeah, this is how it works, I guess. There are some... I guess we can do that checks, because there's one more thing which I think it fails to check, but to do that we have to change this to int, for example. And no, this will be fine. Okay, so there are a couple of questions on topic. Let's go through the questions on topic. So Dashin asks why do you think Clang or Clang is not as popular as GCC? Because it's newer. It's like Clang is the new kid on the block, right? It's a new open source compiler and is gaining a lot of traction and a lot of attention. And in a couple of years, it might actually surpass GCC in popularity. But being a new kid on the block, it doesn't have, all the projects have been using GCC for years, and not all the projects are going to switch. Not all the programmers are going to switch because, yeah, like if GCC works for them, then why should they? Perfect is the enemy of good, and so on. So yeah, apart from it, again, is gaining on popularity, so that's fine. Is it a good idea for ASan to run all the time on end-user machine? No, because it kills performance. Well, it kills. It doesn't kill performance, but you can see here, right, for like the code which we have here, the yellow parts. This is the code which was added by ASan. The checks are and the calculations are pretty lightweight. There is not a lot of math was added here, right? There was like, I guess this is what would have to be executed, well, including the jump, but the jump might not be taken. Has to be executed for every memory reference, so it's not a lot of cycles, but it might be slower. It will be slower, right? So on your normal machine, your normal desktop, you probably don't need it. Now, if you have a fleet of, if you're like, I don't know, operating some huge service of some kind, right? And you have like 1,000 machines, for example, then you might want to experiment by enabling ASan for like 1% or of 0.5% of the machines. And that way you get some detection, but you don't sacrifice performance for all the service. It obviously depends on what the service does. Now, there's also a question, which is a good question about, does this improve security in any way? Like, since ASan can detect buffer overflows, will it prevent them? The answer is yes and no, as in a side effect of the detection of a buffer flow is the termination of the application. This is what ASan does, in fact. Now, ASan doesn't try to make exploitation harder. It does by the way it works, but it wasn't designed to do it. So it would make exploitation harder, but it wouldn't make it impossible. And on some of the previous years' Dragon Sector CTFs, I think Mateusz Jurczyk did create a pawn and exploitation challenge, which was compiled with ASan. And yeah, it was exploitable. It was a little more complicated. There were parts which were actually not compiled with ASan and parts which were compiled with ASan, But the general idea is that if you have, for example, a write what were condition, right? You can override the shadow memory. The shadow memory is writable. You can put there any, you can just like 0 this or 0 this, and then, yeah, then if you trigger the buffer overflow next, you will just like overflow everything like there is no tomorrow. So that's a thing you have to keep in mind. It might give you some additional defense, but it's not a perfect defense by any means. And yeah, and there is no support for the security side of it. It's meant to be a detection tool at the level of developing the application and testing the application, but not on production. That's basically the idea. But it might have some benefits if you want to experiment, but you're on your own. Okay. What's the difference between leak sanitizer and vial grind? So again, leak sanitizer works, I think, by... we can take a look in a second, by the way. It works, it's compiler time instrumentation, and vial grind is, if I remember correctly, is like either instrumentation or a virtual machine. So it's just a difference of how it works. Vial grind can detect buffer overflows and so on as well with some options, but ASan is just faster. But vial grind can work with binaries, if I remember correctly. So, like, you know, like 2 different things, 2 different tools, both of them usable in their own scenarios. Oh, this is not related to the stream, but I will ask it anyway. The skeptic Squirrel asks, how common are stack canaries these days? Stack canaries are pretty common, pretty much everywhere by default nowadays, apart from like, well, okay, not always on by default, like Mink on Windows doesn't have them on by default. But yeah, they are pretty popular. I mean, on CTFs, for example, they're everywhere. Like, you hardly get a challenge without a stack canary. But stack canaries are... I think I did a live stream on stack canaries some time ago, right? It's a known mechanism right now, and there are known ways to bypass it. And it does prevent against some things. Is ASan compatible with ASLR? Yes, it is. It's fully compatible because there is no reason for it not to be. As in, as you can see, the address calculation, like this happening here, right? It doesn't care what the address is. Yeah, the address can be anything. Like, it can be randomized. It doesn't matter. So this is, by the way, a really good question. Okay, there are some more topic-related questions which Foxtrot did write to a separate place, which I should have looked at. How do they catch the crashes? Well, I guess we already discussed that. They catch the crashes by basically looking at the shadow memory. We will look at another case in a second. Is that the red zone that matters for OS development? There was some red zone in OS development, but I don't remember what the term was exactly for, so I cannot answer your question, sorry. Frozen asks, if you could override the shadow memory somehow, would you bypass the sanitizer check? Yes, I already addressed that. Yes, you could. That's a good idea, by the way. So yeah, I'm happy that you came to that answer yourself, basically. Does it hook mallocs too? Let's check. I'm not going to use Godbolt for that. I am going to use this. Let's, yeah, this buffer, right? We are going to have actually a malloc here. So we are allocating, oh, by the way, to do that, we need include, what? Oh, wow. Wow, this, yeah. Sorry, as you might remember from my previous streams, I'm not a fan of the text editor helping me too much. Okay, that's fine. So, yeah, actually testing this should tell us 2 things. First of all, it should tell us, but you know what, let's go back to the other idea. It should tell us if the leak sanitizer is enabled, because I'm not freeing it anywhere, so it's a leak. And does the buffer overflow detection work with malloc? How does it work, if it works? So, okay, we compile it. Okay, we don't need the verbosity thing. We run it. I'm going to be like run it without a buffer overflow to see if the leak sanitizer actually detects anything. Yes, it does. Detected memory leak, and it says 4 bytes were allocated in one object and were allocated by malloc, which was called from line 5. We check line 5. Line 5, it is indeed. And yeah, 4 bytes were leaked in one allocation. So this is perfect. This is annoying while fuzzing, but when testing your application, that's actually awesome. You can disable it, by the way. I think you do leak sanitizer equals 0 or something. No, there was an option for that. Let me take a look. So ASan disable leak sanitizer maybe. Oh, detect leaks, that's it. Yeah, so you can disable it for fuzzing again by using ASan options and detect leaks equals 0. There are some interesting ASan options, by the way, so you might look at it. By the way, there is a small step from including ASan and including ASan with coverage information being gathered for your application. So yeah, we might actually want to look at it in a second as well. Okay, so now for the buffer overflow. My apologies. Boom, detected. So what happens? What information did we get? We get a heap buffer overflow. Again, it's a heap-based buffer overflow, but that's fine. On address, blah blah blah, some basic information. Then it's a write of a size of 32. Did I like match? Did 32 of A's? That's cool. On this line, this is where it's happening. If we scroll down a little lower, we see that which allocation or allocations were actually affected by this write. And yeah, we have it's located 0 bytes to the right of a 4-byte region, which was allocated. This is the 4-byte region allocated by thread T0. So thread, we know which thread, which is also amazing here. So we know there was an allocation of something, and it was a 4-byte allocation, and that's the allocation which was where the overflow began, as in here, right? This is our allocation, and we know that after the 4 bytes in the middle, it actually did overflow. So we get quite a lot of information. That's quite amazing. And we can see that the shadow memory actually has a lot of FA, and FA is heap left red zone. I guess it's like just heap red zone because, yeah, on like heap it doesn't matter. Now, another thing which ASan actually detects, oh yes, and this is done by hooking malloc. And since we did run it with verbosity enabled, we might actually see, yeah, this, exactly. libc interceptors initialized, so it actually does hook some stuff. For example, if you have a buffer overflow, which is using, well, for example, here, right, I'm using scanf. And the scanf is actually doing the writing, but for some reason detected it as well. I think it, like this scanf, which is being called, is actually like from libasan. It's one of the interceptors. It's in the interceptors file. So it actually hooks quite a lot of C functions which do any kind of memory movement and makes sure that whatever overflow is done by these functions is also detected without having to compile the C library with ASan. Because otherwise, if that wouldn't happen, the hooks would not be there. You would have to actually compile the C library with ASan. So okay, we already know that the heap-based buffer overflow is happening, is being detected. We know that the stack-based buffer overflows are being detected. Now, another cool thing is if we would free actually the buffer here, so now this is less of a buffer overflow, more of a use after free back. We can compile it. We can run it. And I'm just going to enter a single A. And we also get a report that there is a heap use after freeze, so it also detects the use after freeze, which are a pretty strong, and usually easier to exploit, depending on your heap manager, of course, but usually easier to exploit bug. So it's great that ASan also detects it, and it detects it, like throws a lot of information at you. Well, the right sizes and the allocation is already the obvious part, but it also tells you where the region has been freed. So it also stores this kind of information. And we can see that it was freed. Where was it freed? Line 12? No, that's line 6. It should tell us actually where was it freed. Here, blah blah blah. Yeah, I don't think it was freed there. I think there is something weird with the report going on, but that's fine. It's like close enough. I would say it's close enough. But it wasn't freed by this function. Cool. So, now, what, as you can see, like in the previous case, by the way, there is a lot of more red zone on the heap, right? Because it's easier to actually, well, given that ASan actually hooks malloc, and if I remember correctly, it actually doesn't only, like, it isn't a thin wrapper on malloc, it's actually its own memory manager. So yeah, malloc is basically fully replaced with another implementation, so it actually understands all of the heap, and that means that it's able to put the red zones in more places, which means that the detection is actually better. How does ASan work with custom allocators? It's a great question from Camillus. Basically that's exactly how I described it, as in it replaces the allocator. So if you have a custom allocator and you want it to work with ASan, you might have to do some tinkering. How does LLVM work? From Przemek. I don't know too much about LLVM, in all honesty. I know that it's based on modules, so it's the code is a little more detached from each other than the case in GCC. And I know that there's a front end, a back end. Like in one, you put the input language, whatever it is, and that's separate from the back end, which is generating the output assembly. And in the middle, I always mix them up, which is the front end and which is the back end. I think the front end is the one where you put, for example, the C language, like the C code, right? It actually emits this, I think it's called LLIL or something like that. I don't remember, like LLVM intermediate language. That's the full name, basically, which is kind of like super simple assembly, and then you can run whatever transformations as in optimizations you need on that, and then whatever the output is being translated to assembly on a given platform. So this means that, yeah, you can, for example, do a backend which outputs JavaScript, and you can do a front end which takes Rust, and you can enter any code which is in Rust, then have it optimized regardless of which language was it originally in, and have it output it in JavaScript, for example, which is amazing. I mean, the architecture is great. Intermediate representation, LLVM-IR. Thank you, Dutch Ghost. Yes, that's correct. There are a couple of other intermediate languages like that. For example, there is Rail, which I guess it was most used for reverse engineering projects. Then there is, for example, Binary Ninja has its own intermediate languages. So there are a couple of those, and I usually confuse the names. Thank you. Perfect. So what else can we check with ASan? I guess, well, we are not going to look at this code because it's pretty similar. What I wanted to look at is basically how does the check for a 4-byte access look like? Because previously we checked how does a access for a 1-byte look like, but for 4 bytes it's a little more funny, right? What if you have a misaligned access? Like it's not aligned to the 4-byte boundary. Is the other side checked as well? So, and I'm actually going to do an unaligned access here. So, or am I going to do it? Yeah, I'm going to do it. So, to do it, we need basically, okay, like C might not like this code, but that's fine. Okay, buff. Okay, so I'm taking the address of the buffer and say that it's actually addressing characters, like individual bytes. And I add A to it. This will be executed first, and then the type will be char pointer. Then I add A. That means A will be multiplied by size of char, which is 1, which doesn't change anything. And then I cast everything to an int again, and I dereference it because it's an address to reference it, and I put A there. So this allows you to do unaligned access to 4-byte of a 4-byte size, right? And this was mentioned as one of the things where ASan actually might not detect some overflows, where and it's mentioned on the official Wikipedia, by the way, where let's assume this is 8 bytes, right? And we have some information that, I don't know, 04 there. And you actually do, so 04, this means that this is fine to access, like let's do it green, and this is a red zone, right? And you give it the address of like this byte, 2, for example, which means the write would be here. It would touch the red zone. But if you check only the address of the first byte, is the address of the first byte correct, and don't check the address of the last byte, or like the whole, you don't do boundary check instead of a single point check, then this overflow would not be detected. Let's see if it's actually the case, because something might have changed in the last time. So we do the calculation for the address again to get the address of the shadow memory. We get the area for the shadow memory, so we get it here. If it's 0, then whatever. Otherwise, we go into this check again. If it's 0, then you just access. And by the way, this is already the problem, right? If it's 0, you don't really, because of this shift, you just lost the bytes. So if your shadow memory is 0, 0, but then after that is like F7, for example, or F whatever, then, and you were addressing the, for example, assuming that the beginning is 0, your index was, for example, 7, well, 7 moved by 3 to the right is actually 0, right? 7 divided by 8 is 0. So here we have, that means that it will be the same metadata for the 7th index as for the 0th index, and it loses that data. And it checks this, and well, this is 0, so this is fine. And it goes into writing the memory, but actually what it writes is doesn't write the memory, this memory, it writes like this memory, like this block, not fully, but like this part. So it doesn't detect all the cases. That being said, to do this kind of unaligned write of a variable which is larger than an int, larger than a byte, and this is it, right? You do have to do this, or you do have to do memcopy of a weird kind. So it's by default, all your code will not do that, and that's fine. That's why ASan doesn't detect it by default, because it doesn't matter in normal projects unless you are doing some really weird stuff. If you're doing really weird stuff, then ASan will not help you detect such edge cases. And this is also important to remember. So it's a great tool. It detects all of the common things, but it doesn't detect edge cases because that it makes sense for it to not detect it to have more performance. Especially, if you're fuzzing, performance is important, right? Okay. So I guess I will leave you at this, and I encourage you to experiment with ASan. If you are doing fuzzing without ASan, do fuzzing with ASan. Your results will improve greatly. ASan is a great detection tool. Even for stuff which does not crash, ASan will catch it. We will do, I guess, questions, and And yeah, that's about it for today. I guess it's just, you know, the beginning of an adventure with ASan. So let's take a look at the questions. Okay, guests writes Gunveil's alphabet letter E. Letter E, well, exploit, right? Unless the chat has some other ideas for anything security related which is beginning at the letter E, which is not exploit, then we can try to discuss that. But yeah, well, an exploit, let's chat about what is an exploit and what an exploit isn't, because that's actually a common source of confusions for people who are not related to security but want to talk about security. And as in, I did see some articles in mainstream press using the word exploit incorrectly. So exploit is actually a script, which uses a vulnerability in an automated way, and that's an exploit. So yeah, that's it. You don't discover exploits if you look for bugs. You don't discover an exploit. You discover a vulnerability, and then if you want to exploit the vulnerability, you have to write an exploit, which is again the script which does the automates the steps to exploit a given vulnerability, right? To use the vulnerability to do whatever is possible and you want to do with it. Obviously, some vulnerabilities are exploited without exploits, as in you can just manually trigger them and do whatever the vulnerability allows you to do. And in other cases, that's not true, and it's better to just write an exploit, especially in complicated cases. You don't want to do, for example, return-oriented programming by hand. You want to write a script for it. So that's E. Unless there is some evil. Oh, evil from Foxtrot. But yeah, evil is also a good suggestion for E. Evil as in... let's zoom it. Evil, and please pronounce it the same way as evil. It's the proper way to pronounce it. Evil. So evil is a great function which is being used by people to make exploitation easy. Well, okay, it's really hard to use evil, especially if you... it's usually in a programming language, which is usually like Python or JavaScript or like Perl or so on, like not a compiled one like C or Java. Evil is the function which allows you to execute some code which is provided in a text form. So it does compilation and execution of the code you provided to in the environment of the running application. With usually little sandboxing, you can try to apply some kind of containment to the environment, and it usually fails spectacularly, like in Python, for example, or in Node.js. There are ways to jump out of the environment if you, as an attacker, control the code which is being executed. Think of a web calculator, for example, where you enter an expression, it's passed to evil to calculate the expression. Then if you can pass some Python code or JavaScript code or whatever, then you might be able to jump out of it, execute a backdoor shell, and yeah. So do not use evil, if possible, on production code. So that's letter E, I guess. Pavel, thank you for the donation. ASan_option donation equals 1, value 20, thanks 1. Thank you very much, Pavel. Cool. Do you know that Microsoft's secure C string functions like str copy s are part of C11 standard? Are these functions from Microsoft? Because Microsoft originally had _save functions, if I'm not mistaken. But yeah, I did see them. I think these in the standard, but it's actually quite confusing because I think there are like 3 different groups of functions which are like the basic functions, but are supposed to be a save version. Well, they usually are a save version, and they're like with _s, with just s suffix, and with save suffix. And I actually confuse which is in the standard and which is in the MSDN. I'm going to take your word, but they are actually from Microsoft and they're in the standard. I I'm not super sure about it. I don't remember, in all honesty. I'm a CTF player. The companies are looking for experienced employees. How can I get a job? This is an excellent question. So, okay, I need to translate one blog post for a long time now from my blog. If you go to my blog, on the Polish side, you can actually use Google Translate for it. I will give you a link. Okay, come on. Waiting. I thought I actually fixed the timeout issues, but I didn't. I need to take a look why. Well, whatever. Okay, this post from 8 years ago. I'm going to give you folks a link. Do put it through Google Translate. Let's look at it from Google Translate. Translate. Yeah. That didn't work as expected. Here we go. Oh, it's the other way. Wait. No. From Polish to English, yeah. Okay, yeah. Okay, so basically the post enumerates ideas what you can put in your resume, your CV, of things which you did after hours or like your own projects, which are not considered professional experience, but they are also some kind of experience. So there's something which you can actually put in the resume. And for example, you can put open source applications. If you have something good on GitHub, like not another calculator example or hello world, but a interesting application library or whatever on GitHub, put that in your resume. If you have written any articles, tutorials, and they have been published somewhere, for example, in a magazine, in a paper magazine, or in some, as in like FRAC, for example, then or POC or GTFO, then totally do brag about it in the resume. If you did any lectures or you went to a conference and you gave a talk, then put that in the resume. If you participated in the conference, you can put it in the resume. It's not as strong as actually giving a lecture, because giving a lecture means you're probably an expert on the subject or close to it. Yeah, well, it means it looks like that in the resume. Yeah, participation is better than nothing, but if you have any talks which you gave, then do not put participation in. If you run a blog, a technical blog, then put it in the resume. If you published an advisory, you have CVE numbers, put it in the resume. And they're like, by the way, if you scroll down, then there's some other stuff here. If you take part in open source projects, like contribute to open source projects, put that in the resume. You can make a portfolio. If you create applications, websites, or whatever, make a portfolio, link to it in the resume. If you have any certificates, if you take part in different competitions, for example, CTFs, do put that in the resume, especially if you or your team won something in a CTF, like won a CTF or were in the top 10, put that totally in the resume. If you are the captain of a CTF team, you are organizing the team, do put that in the resume as well. If you did any internships, this is pretty obvious. That's the usual way you do. You put usual thing you put in the resume. We did chat about applications already. Even they are not open source, you can put them. Sometimes if you do, if you help on some forum, for example, if you're like top 1 in C++ on Stack Overflow, then do put that in the resume. It's appreciated. I think KrzaQ some time ago was like super high on Stack Overflow, like my other moderator. If you run any workshops or you create any zins, as in, papers as in like POC or GTFO, that kind of papers, or FRAC. If you write something like it, create something like that, or manage something like that, or you manage a science club or whatever, do put that in the resume. Portfolio, solve tasks, yeah, that's also fine. If you do any write-ups for a CTF, you can put that in the resume as well. That proves your technical expertise. So if you don't have any experience, but you do actually do stuff, then yeah, you can put some stuff. It makes sense to put some stuff in the resume. It isn't as good as, professional experience, but it's better than nothing. And it proves that you're actually passionate about the subject, right? If a company is looking for passionate employees who like it, who is the hobby for them, they like what they do, then you probably have a lot of such activities already, and you can easily put them in the resume, so do it. Yeah, and then, so that's one thing. The other thing is actually, how do you have your resume and it's beautiful, where do you send it? Well, Google stuff, that's one thing. Ask people. If you know somebody from some company, ask them if they have an opening, ask if they know which company might have, because maybe they don't, but the person is familiar with the security scene, and another company might have. Some time ago, I think at the beginning of the year, I actually tweeted a question like which companies are hiring, and I pointed some people to the thread, and yeah, I did get feedback that it was useful. So yeah, ask somebody who is, you know, visible on the scene to do a tweet like that. Then on Reddit NetSec, there is a hiring thread. I'm pretty sure there is a quarterly hiring thread. Let's see that. So if we go to Reddit, our NetSec is for net security. Then monthly discussion. Yeah, security hiring thread. You might want to take a look at this thread, and every quarter there's a new one. I'm going to give you a link. Yeah, apart from that, you know the usual. You probably want to know people, as in, okay, and don't get this wrong. If you know somebody, you might get information from them about an opening at their company, because some companies usually count on their employees referring specialists which they know, and before a job opening is even public. So this doesn't give you the job, obviously, because you still have to pass all the, you know, hiring bars that the company has, but you get information about there is an opening. So yeah, like knowing people is useful. I guess that's, I'm repeating what usually most coaches say right now on the internet. So, but that's actually true. I don't think I have any other tips. Do you believe there are hidden instructions on CPUs? Yeah, totally. I saw a talk from Christopher Domas, who fast the x86. I guess you mean Sunsifter? Yeah. It's normal. Like there were in the history quite a lot of undocumented instructions. You know, it's not like jump into ring 0 and give me root instruction. It's like something which gives you another arithmetic operation which has a different behavior, for example, or this is something from the history of x86. So x86 is being produced by Intel and AMD, and this is what the current state of things, right? If you know the recent history, you know that VIA was actually also producing x86 chips. But if you look on Wikipedia, it turns out that like 20 years ago, there were 10 other companies who were also doing that. There were like Cyrix, NEC, and like there was another Russian one and some other ones, all doing x86 chips. And each of them had like some funky stuff. And there was a good article, let me look it up, because I know where I have it on my desk, on like hidden CPU instructions from old times. Well, at the time of publishing that article, these were like new CPUs, so yeah. Okay. Now, where was it? Oh, yeah, here we go. That's exactly it, I think. No. I think it's it. Okay, let's jump here. I think it's called like 86bugs.lst, but I need to double check it. It's by Harald Feldman, revision 4, published here, and it has some old stuff. Is it like, NEC? Yeah, like for example this, rarely documented. Do they have undocumented? Yeah. Well, CPU ID, but was undocumented at the beginning. Load all. Load all is probably the most famous undocumented instruction ever, because it was used for memory management on 386 and 286. 286 mostly, I think. Thanks to that instruction, you could actually on the 1 megabyte limited memory space, you could address more than 1 megabyte. I think there's a Wikipedia entry on it. I guess I can give you also this copyright so you can look it up. Here you go, and again it's 86bugs.lst. So apart from like instructions, right? Because instructions is one thing, and these are is not like super hidden. They're like non-documented because the CPU manufacturer doesn't want folks to rely on them. If something is documented, then they have to care about backward compatibility, and they, for example, know that it will be changed in some time. There was some case in AMD CPUs a couple of years ago. Somebody was looking through MSR registers, which are machine-specific registers, which are special registers in CPU which control them. Control the CPU and its behavior, and someone stumbled on some weird MSR registers which were not documented but obviously did something. And after inspection, it turned out that you could use the registers to do memory breakpoints. And you might ask, like, what's the difference between the hardware breakpoints on x86, which allow you to do memory breakpoints, and these MSR registers? And the difference was that these allowed you to do a range-based memory breakpoint, while the hardware debug registers allow you only to do a byte, word, or d-word specific memory breakpoint, and not a range-based one. So yeah, like this stuff happens, and it's not super unusual, and it's there is no it's not like it's being hidden for some malicious reasons. Hack the box job offers. Hack the box has job offers. Okay, we can take a look, I guess. Forkill, thank you for, but I'm going to just Google for it. Hack the box job offers. I don't know. You might want to take a look. I'm not going to. Maybe it's somewhere there. What if your resume is not that beautiful? How would you know what is the required knowledge that is needed for the job? CS is a big, like computer science is a big field. You are absolutely correct, it is. Try, like go for an interview and you will see what they are asking about. You can obviously look also through the job requirements, because it does say something there. Just remember that it depends on the country, right? But in some countries, like if there are requirements, then you actually need to meet not all of them, but like 75% of them. It's fine for you to submit a resume if you meet 75% of them, but it depends on the country and on the the local culture and so on. Apart from that, yeah, I don't know. I mean, you don't have to try it. You have to know your local market or whatever market you're aiming at to know what is being looked for. And well, do remember that there are entry-level jobs as well, right? Like, not all companies require people with 10 years of experience, and folks with 10 years of experience are usually more expensive than folks with like just entering the market. So yeah, there are entry-level jobs. Don't be discouraged if you don't get hired to some other position. Look for more openings and so on, the usual stuff. Which I guess like everyone on the internet repeats all the time. So I guess that's it for today. I would like to thank Foxtrot Charlie for his help. And again, next week and in 2 weeks there are no live streams. I will be back in 3 weeks, and so in 3 weeks, and I have no idea what the topic will be. Do take a look at my Genveil Summer Game Dev Challenge. If you do take part, best of luck. You'll need it. No, it should be fun, so have fun. That's it. Thank you. I'm going to leave you with some music and see you in a couple of weeks. Have a great evening, I guess. Bye-bye, whatever time zone you're in.